is which class? Chemistry class, right? So in the last class we are learning about mixtures. What's a mixture? It's a combination of two or more elements, elements or compounds. There are some properties of mixture. The chemical properties will not vary. It won't be having a definite properties such as shape, size, melting point, boiling point, and it can be separated using physical methods. The chemical properties of the substance will not vary. These are all some properties of mixtures. And the two types of mixtures. We will start with the types of mixtures. The two types of mixtures are homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures means the distribution of the components will be uniform. The components are invisible. You cannot see these components by using our eyes. For example, this homogeneous mixture can be explained using two types, alloys and solution. Alloy, first you can see about solution. What's a solution? Sugar plus water can give sugar solution, right? When you take a cup of water and you put sugar inside that water, it is a solution. When you take salt and put it inside the water, it is a solution. So, when the solute dissolves in the solvent, it is solution. How this solution can be a mixture? It has two or more substances, that is water and sugar. So it is a mixture. How it is a homogeneous mixture now? Consider you have this sugar solution. You have added the sugar inside the water. Can you see that sugar now? After dissolving, can you see that sugar inside that water? So the particles are invisible and the distribution is uniform. The sugar dissolved in the cup of water will be distributed uniform throughout the liquid. So it is homogeneous mixture. Then the alloys. Alloys means when a metal combines with other metal or when a metal combines with other non-metal. One should be a metal combines with other metal or a metal combines with other non-metal, it forms alloys. What's an alloy? When a metal combines with another metal or when a metal combines with non-metal, it forms an alloy. It is a homogeneous. Here also the distribution will be uniform. After the alloy is formed, you cannot see the particles inside the alloy. So the properties are same as a solution. So it is also a homogeneous mixture. For example, when you consider stainless steel, it's an alloy of iron and carbon. Whereas this iron is a metal and carbon is a non-metal. And another example, nichrome is an alloy of nickel and chromium. When you consider this, both this nickel and chromium are metals. This is about homogeneous mixtures. Now, can you guess what is heterogeneous mixture? Heterogeneous mixtures will be opposite to this homogeneous mixtures. When you consider this heterogeneous mixtures, the distribution will not be uniform. You can see the particles inside. So, the particles inside this mixture are visible. This heterogeneous mixture can be understood using two types, that are emulsion and colloids. First you can see about colloids. Consider you have a bowl of water. You break this chalk piece into very small pieces and drop it inside this water. Can you see this chalk powder? Yeah, you can see, right? If you want, you can check it. You break this chalk piece and put it inside the water. You can see this chalk particles, and now the particles are visible. That is proved. Next, when you allow this mixture without disturbance, what happens? When you steer it, this particle will move here, here and there, here and there. The uniform will not be uniform. Sorry, the distribution of this particle will not be uniform throughout the mixture. It will be moving here and there in random. And when you allow this mixture to settle, all the chalk powder will settle in the bottom. So now whether the distribution is uniform, here more chalk powder is here no chalk powder is there. So when you consider a heterogeneous mixture, the distribution of the particle is not uniform and also the particles are visible. And when you consider emulsion, emulsion means liquid plus liquid. In emulsion, we have to add two liquids. Both should be a fluid. For example, have water in a beaker, and when you add oil, it will be seen separately. It will not mix with this water. Whether this oil will mix with water when you add the oil and water together in the same bowl, whether it will mix. Today you try again. Have some water, then you add some oil into that water. That may be oil, kerosene, petrol, diesel. It will not mix with the water. Such here whether it is holding the conditions for this heterogeneous. Can you see the oil inside the water? Oil strains you can see separately. Then the distribution won't be uniform because it is not mixing with the water. Here and there you can see the oil strains. The distribution is also not uniform. Hence it is a heterogeneous mixture. So these two are the types of mixtures. One is homogeneous mixture and heterogeneous mixture. Two types of homogeneous mixtures are alloy and solution, and the next one heterogeneous mixtures are colloids and emulsions. Just if you read once you can get clear idea about the heterogeneous and homogeneous mixture. Then the next topic is, the next one is, consider you have formed alloy mixtures, right, by adding two fluids or by adding two solids or adding solid liquid gas. The many ways are there to form a mixture. And now consider you have a mixture like this. This can be a mixture. Consider you have some rice. Unfortunately, you have dropped some stone into that rice. Now whether you can use this for eating. Now there is a necessary to separate these mixtures, right? You have to separate this rice from the stone. So we need to separate the mixtures sometimes. All the cases when you consider this water and oil, if you pour water in the oil, what happens? It is useful for nothing. So now we have to separate this to remove the impurities or to get the needed things, that is to get the useful things from the mixture. We have to separate the mixtures. For that what we do is we use many separation techniques. What is used? Separation techniques. Grade 6 you have learned about separation techniques. Grade 7 you have learned about separation techniques. Now what do you know about this separation techniques? From your last classes, what do you know about this separation techniques? Can you say any 5 separation techniques? Hand picking, winnowing, sieving, filtration, distillation, fractional distillation, separating funnel, chromatography. These are all the separation techniques. So now you understood what is the need for separation, right? In some cases we are in need of separating the mixture. Now you can learn about this separation techniques. There are many separation techniques. Now you can learn about this 4 separation techniques in today's class. The first one is hand picking. For the example I said for the separation techniques, that is when you have stones in the rice, you can remove it using your hand. Your mother will take it using her hand and throw it away, right? So when you separate using your hand, that may be from rice or any grains, it may be dal, it may be wheat. When you can remove the impurities using your hand, you remove it using your hand, right? That is nothing but called hand picking. The second one is sieving. From the name even you can say what is sieving. Sieving is using a sieve. What's a sieve? It will be a circular shape. Small holes will be there. This is a sieve, right? Your mother will take the flour in the sieve and do like this so that the impurities will stay in the sieve and the neither thing, that is the good flour, will be collected down in some vessels. This is nothing but sieving. This is one sieve. Other sieve we have in construction site to sieve the sands. Have you seen this? This is a sieve. What we will do? Somebody will be throwing the sand and this stone mixture through to this. The big sands will be collected here and sand will flow in the back of the sieve. This is also other sieve. This is being used in the construction site to separate the sand from the big stones present in the sand. So this is sieving. For sieving, the particles should be of different size. For example, sand and stone. This will be in different size. And some impurities in the floor. Floor will be very small and the impurities like stone and other things will be of varying size. When the two substances in that mixture is of varying size, you can follow this sieving. Then the next one is winnowing. What is winnowing? You have already learned all this. What is winnowing? Winnowing means separating using wind. What happens means a person will be standing. They will be having the food grain with the waste material. Consider the paddy field. When they harvest, they will separate this paddy from the field and they will take the rice. Then they will beat so that the husk present in that paddy will be removed. Now they take that together and in a wind area, there should be heavy wind. In that area, they throw this from a particular height. What happens means the food grains will be of weight, right? That weight particles will be collected here and the husk will be float to the wind. The husk will float to the other side because of this wind. This is nothing but called winnowing. That is using the wind how we can separate. Then the next one is magnetic separation. This is nothing but using magnet. From the name even you can say, see, this is using hand, this is using sieve, this is using wind and this is using magnet. How you separate using magnet? What should be there when you want to use a magnet? When you want to use a magnet, there should be a substance which is attracted to magnet. Consider you have rice and you have sugar. Can you separate this mixture using the magnet? No, right? Consider you have rice, some iron pieces has fallen inside. Can you separate this particular mixture using magnet? Yeah, because these iron particles are attracted by the magnet. For example, in a bowl you have sulfur powder and in that you have iron fillings. Now when you show a magnet here, what happens? All this iron fillings will get attached to this get the sulfur powder in this bowl and all the iron pieces get attracted to this magnet. This is why you separate using magnet. I repeat, hand picking is separating using our hands. Sieving is separation using a sieve. In home we use a sieve in round shape, you do like this, that is sieve. And construction side for separating sand and stone, you separate the different sieve. Next one is winnowing. Using bin you can separate. That is, you can also try. You just take a table fan, switch on the table fan, and you take some rice and some unwanted dust. Dust means some grass or something which will flow in air. You take that, and when you show like this in that air, when you put that mixture in front of the fan, what happens? Have to switch on the fan. The rice will flow or will be collected in the down, and this particle which will fly in the wind will move off. So you can try today, okay? The next one is magnetic separation. Magnetic separation means using magnets. When there is in the mixture, if there is a particle which is attracted by the magnet, only when there is a particle which can be attracted using this magnet, you can use this technique. So when you show the magnet in the mixture, this particles which are attracted by the magnet will get attached to the magnet, and the remaining we can collect it separately. So I hope this is enough for today. The next one is sublimation. You know that, right? Sublimation. There is a funnel like this. You have to take ammonium chloride here. You have to heat using the burner. Have to close this lid. This ammonium chloride and sand mixture here. You have to burn. Can you remember this sublimation of ammonium chloride? How this is used in separating? This ammonium chloride, what happens means, when you apply heat to this ammonium chloride, it will start evaporating. Without changing into gaseous state, it will turn to, without changing into liquid state, it will directly go to gaseous state. When it starts evaporating, and when it is reaching the neck of this funnel, here the temperature will be less, right? Again it will deposit as ammonium chloride in the neck of the funnel. So all the ammonium chloride will deposit here, and the sand particle will be collected in this funnel here. So this is used for separating solid. Ammonium chloride is a solid, sand is a solid. In sublime solids means when you heat a particular solid, it should directly change into gaseous state. In such cases, you can use this sublimation to separate. One of the solid should be sublime solid. Here in separating ammonium chloride and sand, we can use this sublimation method. So 5 techniques we have learned today, right? Sublimation also. I hope you are all clear about today's class. You have learned what is the two types of mixtures, then what's the need for separation, then 5 separation techniques. In the next class also we are going to continue with the same topic, separation techniques. That is some other techniques to separate, like filtration, evaporation, etc. So this is enough for today. Just these are all like stories. So if you read the book, you can get clear idea about the content of this headings. I hope you are all clear and understood today's class. We can meet in the next class. Thank you, students.